In this video, I want to go over coordinate covalent bonds. So far, we've talked about covalent bonds, where each atom will provide an electron, and both atoms share the pair of electrons in a covalent bond. And we've talked about ionic bonds, where one electron is transferred from one orbital to another orbital, and the electrons are not shared, but a bond is created by electrostatic attraction. A coordinate bond is similar to a covalent bond. Both covalent bonds and coordinate covalent bonds share electrons equally in a bond, but in a coordinate covalent bond, the electron pair is provided by one atom. You can use this character of the coordinate covalent bond, where one atom provides the electrons that both atoms share to stay in the bounds of the octet rule. Let's look at ammonia, the ammonium ion. Nitrogen has 5 valence electrons, and each hydrogen has 1 valence electron. And when these are bonded to the nitrogen, each atom shares an electron to make a bond, which works very well with the octet rule for the nitrogen. And hydrogen can only have 2 electrons. So the nitrogen has 8 valence electrons. So here's 1, 2, 3, 4, 5, 6, 7, 8. So this works very well with ammonia. Moving to the ammonium ion, we have 1 nitrogen and 4 hydrogens. So the nitrogen has 5 valence electrons. There are 4 hydrogens with 1 valence electron each hydrogen. When we add the hydrogens to the nitrogen, if we add the 4th hydrogen, we end up having 3 electrons in the bond between nitrogen and hydrogen. This would make nitrogen have 9 electrons. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9. This would not work with the octet rule. What we can do is build up the molecule the same way we did with the ammonia molecule, where nitrogen would have 5 valence electrons and hydrogen has 1 valence electron. So this fits the octet rule, where the nitrogen has 8 electrons in the valence shell. So there's 1, 2, 3, 4, 5, 6, 7, 8. And the hydrogens can only have 2 electrons, and each hydrogen has 2 electrons. So the 4th hydrogen has to have an empty orbital. So it has to be a hydronium ion, where both of these lone pairs on the nitrogen can be used for the orbitals on the nitrogen and the hydrogen. So the nitrogen provides the electrons, the bonding electrons, but both atoms, nitrogen and hydrogen, share the electrons.